So we'll see some more applications of the remaining types of the lines. For that I have to create one object. Suppose such kind of three-dimensional object is there. Okay, so such kind of stepped object, three-dimensional object we are having. Okay, and suppose one cylindrical hole is cut through hole in this part of this object, right action part. It is through hole, right from top to bottom. Through hole it has been cut cylindrical in this part. Okay, so different kinds of lines and its implementation we are going to see here. What is this? This pink line is showing us as good as center line, but just see what I am going to create. It seems to be center line, but left extreme and right extreme ends are thicker. Means what? This line is nothing but cutting plane location, or we can say through this line only the cutting plane, the hacksaw will pass, and it will convert, or it will cut this object centrally, and it will convert into two halves, rear half, front half. Okay, so this is the significance of that line. It shows through which plane the cutting element will pass through that body, and it will cut that object into two parts. Okay, so this is the significance or application we can say. Suppose this is A and A. This is the method of showing the cutting plane. Means what is the significance of showing these arrows? One has to pick the saw, cut this object, okay, and this part, front part, just you have to pick from here after cutting and throw as a scrap. And these arrows, what those are showing remaining part, just which is left part behind this cutting plane. In the same direction you have to observe and show its effect in the conversion of 3D into 2D, that is orthographic positions. Okay, so this is the cutting plane. Okay, that I have shown here. After that, this is the visible outline. First kind of line, continuous thick line, visible outline. Some more dimensions I will show you here. So by that, just will revive extension lines. Okay, on this dimension line, at least it should be 10 mm. More than that, it is acceptable, but less than that should not be drawn. This dimension line should be drawn at least at a distance of 10 to 12 mm away from the visible outline of the object. Okay, and those dimensions now just you have to put here. Suppose this is of 120 mm length. Okay, and this part is carrying 50 mm length. That also we can show. See here how to show the dimensioning. Yes, just you have to extend from each and every step. Go on extending in this way. dimension line here in this way, another one dimension line, vertical dimension line, again right 30 dimension line. This three-dimensional object is three-dimensional. Only three angles are well maintained here. Which are those? Just see. As good as this is origin, 30 degrees towards right and 30 degrees towards left. So left 30, right 30 and vertical. Only three angles are well maintained here. This is called as three-dimensional object, which is nothing but it is also called as isometric view of the object. Okay. 3D object. Angles are 30 degrees right, 30 degrees left and vertical. Only three angles are successfully used here. Suppose this is carrying 20 mm thickness. This is of 70. So naturally it is 120 minus 70, it is 50. Width again, I will show that width here. Dimensions should be written above the line, not casually at all. Suppose you have to show its height 20, its height is total 50. One should not write height 50 in this way. It is a very wrong method. One has to write 50 in this way. Dimensions should be written normal to that dimension line, over to that dimension line. Okay, not below. It should be written above the dimension line. That too, dimensions should be normal to that dimension line, like this. Just see here. 20. Actually, this is 30. So these are extension lines: continuous thick line, continuous thin line, extension line, dimensional arrows, arrowheads. The proportion also you have seen last time. These are the dimensions. This is the cutting plane or section plane. Okay. Now this hole, it is thoroughly drilled in this way, in this object. Arrowheads are shown here. Okay. Suppose we have to draw its front image, means we are observing this object in this way, in this direction. Suppose this is x. X is in the direction of observation of this object. So in that case, in this direction, when the observer will observe this object, the outline, the contour will be visible to him. But what will happen with this hole? This hole is drilled in this way, vertically, in this object. But in this direction, it will not be visible to the observer. But still it should be shown. Then, third kind of line, that is dash medium thick line, we have learned. Okay. So that line will help you here a lot. Suppose in front view, how it will look like in front view? Front view of the object will be like this. It's very simple. This object will look like in this way. Suppose this is surface A as it is. I have drawn here. But now this object, this surface is visible to me in the direction of x, but the hole is drilled in this part here, that too vertically. Okay, and totally it is hidden. It's not visible to the observer in this direction of x. It is visible in top view only. When you will observe from top this object, so naturally this hole is visible to you. In that case, you can show its circle. But in the direction of x, for constructing its front image elevation, in that case this hole is not visible. Okay, so one should show the hole effect in this way. Vertical center line I will create here exactly at the midpoint of this part. Okay, and suppose this hole is carrying a diameter of, I haven't shown it here, leader line I have created here. Suppose this hole is of 30 mm diameter. Then same 30 mm diameter you have to show here. Means what? 15 on either sides. 15 mm left and 15 mm right. On either sides you have to mark the distances. And dash medium thick line, how to construct in the table we have learned. Small dash, small space, small dash, small space. Likewise, dash medium thick line you have to create. What does it mean? What is the significance or application of these lines? This is the center line. Okay, where the hole has been drilled, and this is the surface A, and in the direction of A, without cutting, we are not cutting at all. So in that case, when you will observe, this hole will not be visible to the observer. That's why dashed medium thick lines will show you to the observer that it will predict that in that direction, somewhere on the back side of this surface, some kind of hole is created there. Okay, so these dotted lines or dashed medium thick lines will show you the hidden elements of the object. Okay, now next part is hatches. Suppose files, what we are going to do? We are going to cut this surface, cut this object centrally. So it will be ultimately converted into two identical halves. Okay, so what will happen? Just I will illustrate. After cutting this front part, usually one has to throw as a scrap. So only remaining part is the ours part only. We should take care of that part only. We should get concentrated over that remaining part which is just behind the cutting plane, leftover part behind the cutting plane. So this is a remaining element of that object, remaining half of that object, that too with us only. Rest other part, that is front part, front half of this object, after cutting it has been thrown as a scrap. It is no more with us. Yes, same kind of harmony we have to maintain at the base also. So semicircular slot will remain after cutting. Cutting plane has cut that cylindrical hole. That's why the semicircular part will be visible to us. Now nothing is hidden. Hole is totally exposed to us. Now what will happen? After cutting, this surface will not be plain, will not be smooth. Because of the teeth over that hacksaw, the serrations will emerge over this surface. And those serrations are nothing but the hatches. Last application or use of that continuous thin line we have enlisted in the types of line table. It is nothing but hatches. These are nothing but the hatching lines which are emerged, or we can say also simply scratches which has been emerged over the surface where the teeth of the saw has touched or cut the object. So these lines are called as hatching line. Now while cutting, what happens? As it was here, one full cylindrical hole. Now cutting plane will not touch. There are no more chances of getting touched the cutting plane to that semicircular part. So this should remain unhatched, and the surface over or to which the saw has touched or cut, that much surface only should carry hatches. These lines are nothing but hatching lines, or simply hatches, HATCHES. Okay, so you have seen application of continuous thick line, continuous thin line, dash medium thick line, after that center line, then cutting plane, that is continuous thin chain with thicker ends. Okay, that also you have seen, and these are the hatches. Okay, now leftover part is another kind of line. It is yet to be learned, that is continuous thin wavy, last kind of line, break line, continuous thin wavy, as well as center line, locus line, that also we have to see. Center line of locus line. This is all about the hatches. Okay, just I will erase it out. Now what is the application of locus line? Center line we have seen, locus line. What is locus line? The locus is nothing but one path. Locus, point, the path created due to the movement of the point in the space in this way. Okay, I will show you locus line. Suppose such kind of mechanical arm or lever is there. This is the center line, fulcrum point we can see, and this arm tends to move or fulcrate or oscillate in this way about this center or fulcrum point about this. So path of this hole or arm, it can be shown like this by using such kind of curved continuous thin chain, which is nothing but it is called as locus line. It shows the locus or path of that arm, mechanical arm, which is getting swung about this center. Okay, oscillating point is about this. This arm will oscillate in this way, and the path, it is nothing but the locus line, which is nothing but the curved continuous thin chain, as good as center line, but it is curved one. It shows the path, so it is called as locus line. Okay, this is all about locus line. The application of short break line, that is continuous thin wavy break line, where it is required, where it is used, we will see. Suppose we are having a very small piece of paper available. Okay, drawing sheet we can say, very small, and on this paper, if we want to create large objects, show large objects, say one example I will show you. Scale, suppose we are having 1 meter long scale and this paper is very small, drawing sheet is very small. So in that case, how to show that 1 meter long scale? That on this space constraint, it is very small pages available with us. So in that case, what is the procedure? I will show you. Continuous thin wavy line will show you its application, its significance. What you have to show, just you see. Break line, short break line, how to create. Suppose 0, 1, 2 are the starting digits. After that, simply 98, 99 and 100 centimeter long. The short break line, that is continuous thin wavy lines, you have to create here. Yes. So this is the way to show implement the wavy line, that is short break line, for showing the 1 meter long scale, that too on a very small page. Okay. Intermediate part will be remaining same. Just starting digits 0, 1, 2. After that, middle part will be same. Only it will carry digits and it will end with 100 centimeters. So such kind of scale, by cutting short break lines, the two with full length of 1 meter, we can show on this page. So this is the method of showing or implementing different kinds of lines for different purposes, applications, while constructing the sketches, drawings for the entire syllabus of engineering graphics, as well as engineering drawing, machine drawing, whatever it may be. All these lines should be implemented, should be drawn in this way properly.